All right. Isaiah. Nope, wrong class. Oops. All right. Farhan. Jennifer. Are you here? Yes, she's back there. What's that? Mitzi. And then Olivia. Lee. Angel. Not here. Ritzy. Dallas. Olivia. All right. Jasmine, you can take your computer. You can go next door while we go over things. You can leave most of your stuff. That way you can look over the stuff you need to before the test.
Atomics, they're like so reactive that they're like they have to never alone. So they.
All right, ladies and gentlemen.
You have to write it with the two.
Maria. Cynthia. No, sorry, that's you. You're Steve.
You're big. You're big.
Thank you.
You're up. Julia. Austin. Diana. Now that's you. You're welcome.
That's right, Mom.
Isaiah. Farhan. Jennifer. Who's that? Close. Olivia. All right, ladies and gentlemen, let's go through and give you some answers and see if you have any questions. Again, ladies and gentlemen, where I would begin is I would take a look and I would make sure that I have added up all the points on each page correctly to the number down in the corner. And then I would make sure that I have added the corners up correctly so they total up to what the total is on the front page, because if I did not do that, I did not give you all the points that you have earned. All right. All right. Okay. Oops. Okay. here are the answers to the first two questions for you, ladies and gentlemen. So there were your formulas. There were your names, ladies and gentlemen. Down here is what would happen to the compounds if you put them in water. The ones that are aqueous, you can see what happens, and the ones that are a precipitate, you can see what happens. The one is the version B. The other one is version 2, and it's IDD, just so you know, so that you're looking at the correct one when you're doing this, ladies and gentlemen. So this is IDB up at the top. That is IDD. Does anyone have any questions? Good to go? Yes.
So for the second one, the lithium dichromate,
Yep.
I have the exact same thing except that I just put parentheses around the CR207.
Which is not correct, sorry. You only use parentheses and actually here, I'm sorry, there should be a 2 outside of these parentheses. You only use parentheses if you're putting a number outside it. Okay? You'll only use parentheses if you're putting a number outside of it. So this should have been a 2. Yes, sir, Austin.
For the third one on ID B.
The number 1 or number 2?
Number 1.
Here? Yeah.
Is it supposed to be ammonium phosphide or fate?
Good question. Good catch. Phosphide. IDE. So please make sure I've graded that right on those of yours who have them. If I did not give you a point for that, you're going to have to put a note on there and ask me to return it because I don't know if I looked at my key when I graded that or not. So, good catch. Thank you. Any others, ladies and gentlemen, before I show you the next page? Okay, so for this one, here's your substance formula. What you're starting out at, this is 2 points in the problem, 1 for setting it up right, 1 for using the right mass. Your conversion there, 3 sig figs in your answer, ladies and gentlemen. And then I did not matter if you put the neon here, but you had to have the unit of liters here. Okay? For this one over there, I'll move that stupid thing. Okay, so we started out with this many formula units, got it into moles. Formula mass here over 1 mole. Final answer there, ladies and gentlemen, and the unit of grams. You did not have to have the formula compound there. You should have had it up here. Okay. For here, ladies and gentlemen, taking the grams, converting it into moles. Grams of hydrogen, converting it into moles. Grams of oxygen, converting it into moles, dividing by the smallest one. Ending up with this ratio. That's our empirical formula. The formula mass for that compound is this. The mass of the molecular compound divided by the mass of the empirical means that that formula is that many times bigger. That's what you should have gotten from it. Okay? That's what you should have gotten from it. Okay, for this one here, ladies and gentlemen, taking the grams of each one of these things, converting them into moles. By the way, there were people who for sodium put S, and then you accidentally used the wrong formula mass because you used the wrong symbol. And if you did that, it messed up your problem from there on out. This is the formula that you should have gotten, okay? C5, H8, N1, Na1, O4. Total of 18 points on that problem. Questions?
I have version 2 and I don't have that problem on my test.
I see. Oh, wait a minute. Do you have version C as well? Look at the letter on the top. If you have the blue copy, what version do you have? If you have the blue copy, look at the letter on the top where it says ID. Does it say D or C? D? C? C? Okay. All right. Well, that's fine. I got another copy for you to look at then. Sorry. So you guys are good with the first one. All right. If you have IDC at the top of yours, sorry, there's the two problems that you had on that page. Okay? There's the two problems that you had on that page. And I will put yours up after I put the others up. Sorry, I didn't think I had IDC out there for you guys. Okay? So, again, 3 sig figs to start, 3 at the end, 3 sig figs to start, 3 at the end here. Okay? By the way, if you're going to end up in molecules, if you're going to end up in atoms, it is going to be a number that is times 10 to the 20 something. That's what you're going to end up in. Okay? Grams, you should end up with a number, normal number, in the tens, in the hundreds, somewhere like that. But if you're going to end up in formula units, in atoms, in particles, you're going to end up with a number times 10 to the 20 something. All right. Okay, so now let's go to the next page. All right. There's version B. Here's version D. And I will throw up version C in just a minute. Okay. So again, these problems begin with you writing the correct formula. And I hope you notice the IT ending because that is different than the AT ending on both of these. Figured out what the total formula mass was for that compound, what the total formula mass was for this compound. Took the part divided by the whole, part divided by the whole, part divided by the whole, end up with percentages that should come up to near 100. Same thing here. Part over the whole, part over the whole, part over the whole. Remember, there are 2 of these here. That's why this is double what it normally is. Okay? Questions? Taking liters in both of these problems, converting it into atoms, okay? Writing the formula first, taking liters, moles, moles to molecules, molecules to atoms. Again, a number that ended up in the 24th. Why? Because we're talking about very small pieces of something. 3 sig figs in this number, 3 sig figs here. Formula again, based on the name, okay? Taking the liters, getting it into moles, getting it into molecules, and then molecules to atoms. Answer again in the 24th because we should end up with a very large number of those. Questions, ladies and gentlemen? Okay, for those who had version C, yours looked a little bit different. Not much. Same compound there. Again, getting it into moles, getting it into molecules, getting it into atoms, times 10 to the 24th again. Here we're finding the mass from molecules, molecules into moles, moles into grams. Final answer in grams, ladies and gentlemen.
Where did we get the 6 atoms?
2 here and 4 here. So that's made up of 6 atoms in that one molecule. So the smallest part of that is a molecule. But we can talk about the pieces that make that up still, and that's where the atoms come in. Okay? Okay, other questions? Okay, we'll start with C here before I take and I switch it. Okay? Again, similar to what the other people had, there was our empirical formula after we take our grams and get them into moles, divide through by the smallest amount. Empirical formula we got. Now we use the molecular mass of this instead of that 216. That gave us 2, which means we just doubled everything here, ladies and gentlemen. Okay? Just doubled everything there. Anyone need more time with this one?
Wait, how'd you give us the points for 30, the 2, and the 1? Is that are those individual points, or do we get a point for all of those?
You got a point for getting them all. So you got a point for getting this correct number here. You got a point for knowing to divide it by the smallest one. And then you got a point for having the correct ratio when you were done.
Okay, can you look at mine?
Sure.
So give me a point for these 2, right?
Yep.
All of these, both of these.
Yep.
And then for this one, you
Yep.
give me a point for these 2.
Well, but if you look up there, I'm not giving that person a point for the 2 and the 1. There's no check by it.
Yeah.
So I gave you that. Well, because you should get this formula. You should get this ratio. Okay? You did. Now, where you lost 3 points was that you never went to the molecular. So you never figured out what this mass was. You never took this number divided by that mass, and you never then wrote the molecular formula. That's where the other 3 points came from. Okay?
I thought it was for this one.
No. It just, you didn't get a chance to finish, or you didn't get finished with it, or whatever it was. Okay? All right. All right, ladies and gentlemen. This. The next page for D. The next page for B. Okay, so here again, taking everything from grams, converting it into moles, dividing by the smallest amount, getting our ratio, ladies and gentlemen. Same formula as the other group had. Okay, same formula as the other group had. Here we're taking our grams, we're converting it into moles, then we're converting it into liters, writing our formula up here. State of matter doesn't matter for these things. State of matter is just that. What state of matter it's in. Formula for that compound is just what you see up there. Now, the formula for this compound is different, not because it's a gas, but because it's one of our diatomics. So that's why there's a 2 here. That's why there's not a 2 up there by that one. Same thing here. Again, the 2, taking the molecules, getting it into moles, formula mass, and then into grams. Same exact problem, just a different starting number to begin with there, ladies and gentlemen. Questions? All right. Number 9 for you. Your last one. There's the last one there. You can't see the number I started with here, but it was 5.33. Getting it into moles. Formula mass over 1 mole. Getting it into mass. Again, had to write the correct formula here. Here, taking the grams of each, getting it into moles. Sorry. Okay. Getting it into moles. Dividing by the smallest one, getting that number, finding that formula mass, taking 108 divided by that number, and then writing the correct formula. Questions? Okay. For C, You had this one. That was your compound that you were finding the percent composition for. When you write the name, here's the formula mass. The part divided by the whole gives you this percentage. The part divided by the whole gives you this percentage. The part divided by the whole gives you this percentage. But remember, there were 2 of these in your formula. That's why that's times 2. Questions? And then for C, you had one more to show you, and that was this one. Again, taking what you're given, getting it into moles, figuring out the moles of each, dividing by the smallest one, gives us that ratio. That's the formula that we were looking for there. Questions? Yes, Cynthia?
How come I have the same thing as you, and you didn't get, you took 1 point away?
So I give you 17?
Can I put grams next to it?
Well, you never divided these by the smallest number.
I did.
Okay, but you never showed me that,
I put
You
it
said
right
like-
there.
and you couldn't put it under there? I'm supposed to know what that means?
Yeah, because I put it here, divided by all of these. It's kind of common sense.
No, that is not.
Okay, then how
Common
else do you
sense.
think I got?
I don't know. That's the point. I don't
I
know.
literally have the number right there. Just because it's not underneath there, I literally put the divide sign right there.
I know, but how
What
can you
else
divide
would
a
we divide?
formula by a number?
Whatever.
Okay, we're good then?
Yeah.
Okay. All right, ladies and gentlemen, here are your bonus questions. And by the way, I had an idea of what the answer should have been, but if you had a reasonable answer, I would have accepted it. So they're not in the same order on each test, but they are the same bonus questions. So 3 elements that make for a good summer day, ladies and gentlemen. These were the 3 I was looking for. And I'm looking for the elements. The elements, because then the elements make that work. Okay? Now, some people use fluorine instead. I accepted that as well. So, again, had to be 3 elements, though. For number 11, or the other one, even though it's been warmer than normal, we hope for these 2 elements bring us this summer. Helium and astatine would bring us that. Questions? All right. Nope. Hang on. I gotta find the other one. The last page. Okay. Here are the other 2 bonus questions. Okay. 4 elements will bring you luck if you find one on March 17th. Chlorine, oxygen, vanadium, and iridium. Over. And then with Easter right around the corner, these 5 elements bring a child's favorite friend this time of year. That's what I was looking for. If you gave me something else that was appropriate, I should have given you points for it. Questions? If I made a mistake grading your test, if I did not give you enough points, if there's something that you think I did wrong on it, please, you need to put a note on it and either give it to me or you need to bring it to me and talk to me about it, because I just will not magically fix it unless you do. Okay? Now, again, I will tell you why I graded it the way I did, but if you can make a point like that one at the start where Austin said it was supposed to be an IDE ending instead of an AT ending, if I misgraded that, you should let me know. All right, ladies and gentlemen, questions? All right. Let me go grab somebody real quick first. All right, Jasmine, can you come back, please? Thank you. Rocio, any questions? Okay, good. If you do, please let me know. Okay. All right, ladies and gentlemen, so here we go. If you have something highlighted on your grade sheet in orange, it is because it is missing, which means it is lowering your grade. I did not even bother to put put homework into this, ladies and gentlemen. So you're looking at labs, quizzes, and tests. That's what your grade report is based on. Go. Cynthia. Olivia. Grazie. You're welcome. You're welcome. Sophia. You're welcome. Isaiah. Jennifer. Ava. Olivia. Rose. Anna. You're welcome. Aiden. Farhan. Lizelle. Sure. All right, ladies and gentlemen, so that is the grade that is in the grade book right now for you. Again, if you are not missing anything, you do not have to worry about anything. If your percentage on the test was under a 70, which since it is the only test you have taken, if you look up at the top on in progress, whatever percentage it's showing there for your test, that is what you got on the test. You could also divide the number of points you got divided by 75 or look at the top. If you got a 60% or less, you have until the next test to do a retake, ladies and gentlemen. You need to show me your corrections on your test. You need to then come in and do the retake sometime between now and the next test, which will be about 3 weeks from now. Okay? So again, if you got less than a 70%, you can improve up to a 75 by doing a retake on it, ladies and gentlemen. Are there any questions? If you are missing a lab, ladies and gentlemen, get it in. Get it in. But I will tell you this, on the on the labs in this unit, if you are turning them in on time, you will receive a bonus of getting a grade of either an A or a B if you achieve that. If you decide that you're going to turn it in late, you will get a maximum grade of a C in this unit on your labs. So your labs need to get done and need to get done on time and turned in to me, okay? And I will reward you for doing so, okay? If not, C is an average grade. That is what you will receive. Questions? Excellent. So, ladies and gentlemen, then put everything away except for your computers and let's talk about gases today, ladies and gentlemen. All right. Oops, need that. Okay. Gave you your new EISN today, ladies and gentlemen. Okay? We are going to start looking at gases today. Just a couple of reminders. Anything that is missing in the grade book, the things that I have highlighted in orange on your sheet, those are in as zeros right now, ladies and gentlemen. The only way you can fix that is to take care of it and get it done. Okay? Anyone have any questions on the grade reports I gave them?
Do you want the test back?
Nope. They're yours. You can keep them. I got other versions I can give people if they haven't taken it yet. So, all right. So, with that in mind, ladies and gentlemen, here we go. Today, then, we are going to start talking about gases. Okay? That is what this unit is on. In the last unit, anytime we talked about gases, the gases were at STP, standard temperature and pressure. We will explain better what STP is in this unit, but gases are no longer at STP, ladies and gentlemen. That's what we're talking about. What happens if we're not at a standard pressure? What happens if we're not at a standard temperature? So, here are the topics that we will be covering. We're going to quickly review gases. We're going to talk about the pressures that affect the gas, and we're going to talk about pressure itself. And by the way, there are two different definitions for pressure that we have. One for just pressure that an object can feel, and one specifically for pressure by a gas. We're going to show you how to measure temperature, what STP is, and how to convert from something called Celsius, degrees Celsius, into Kelvin. We're then going to talk about Boyle's law, Charles' law, Gay-Lussac's, and Avogadro's law. All four of them are gas laws, ladies and gentlemen. Then we will get into what is called a combined gas law. And then finally, ladies and gentlemen, we will finish up with ideal gas law, and then some other special relationships that gases give us. That is the unit. About 3 weeks, we will be done with it. Questions? Wonderful. So here we go, ladies and gentlemen, a quick review of gases. Again, this was when we talked about solids, liquids, and gases in the first part of this course. Well, we are specifically looking just at gases now. Gases are unique because they do not have a definite shape and they do not have a definite volume. Gases will take up however much space you give them, and they will completely fill their container. So they will also take the shape of their container. Now, liquids will take the shape of their container, but they don't fill their container necessarily. This pitcher is only half filled with liquid. The pitcher is completely full, though, between the liquid and the gas in it. Okay? Gases have high energy. Gases are moving very fast. They are far apart. They collide with each other. Matter of fact, they are so far apart that we can't even see them most of the time. Questions? Good. So, just a reminder, ladies and gentlemen, there are a couple of different types of relationships that we have talked about. One is a direct relationship, a relationship where as one variable changes, the other goes in the same direction. So with gases, if we change one thing about a gas, something else has to change. Now, because of that, those two things may be going in the same direction, maybe both increasing or maybe both decreasing. That would be a direct relationship. Mathematically, a direct relationship, the two variables are divided. That's what makes it a direct relationship. So, for example, the speed a car is traveling is distance divided by time. The longer you drive, the further you will get. Meaning, as time increases, distance increases. That is speed. That is an example of a direct relationship. Then there is what is called an inverse relationship. In an inverse relationship, one variable is going up, the other is going down. One is increasing, one is decreasing, meaning they are going in opposite directions. Here they are going in the same direction. That same direction may be both increasing, that same direction may be both decreasing. Here they are going in opposite directions. And again, because we are doing the opposite thing, the mathematics is exactly opposite. Instead of dividing these, we multiply these things together, ladies and gentlemen. Okay? We multiply these things together. Now, an example would be energy added to a substance. If you add energy to water, the water is going to change temperatures. However, if you have more water that you add the same amount of energy to, then the change in temperature is going to be smaller. Meaning the more water you have, the less temperature change you have. Those are two things going in opposite directions. Questions? Wonderful. Second type of relationship, ladies and gentlemen, is it a constant relationship or is it a non-constant? A non-constant relationship, as one variable changes, the other changes at the same rate. Not necessarily going in the same direction, but it is changing at the same rate. Meaning if this thing doubles, this thing doubles. That is what we mean by the same rate. And because of that, ladies and gentlemen, if we look at a graph, we will get a straight line. Straight lines mean constant. And we are going to be graphing a bunch of stuff in this unit. And when you see a straight line from a graph, it means there is a constant relationship. Now, by the way, this line is going in what direction? Up. So is this an inverse or a direct relationship? It is a direct relationship. Anytime the line is going up, it is direct. Anytime the line is straight, it is constant. So what does that mean if our line is going down? It is an inverse relationship. And again, doesn't matter how the line is going up. Up means constant, down means inverse. Okay? So here we have a line that is a what kind? Inverse, because it's going down, but it's also straight, so that is constant. Okay? A non-constant relationship, one variable changes, the other variable changes at a different rate. At a different rate. Not a different direction, a different rate. Those will be a curved line. If your line is curved, it is a non-constant relationship. By the way, inverse or direct? Direct, because the line is still going up. Anytime the line is going up, it is a direct relationship. Inverse or direct? Constant or non-constant? Non-constant. So those are two different ways of looking at a graph. What direction is the line going, and then what shape does the line have? Direction, constant, direction, inverse and direct. Shape, constant, non-constant. Okay? So, constant relationship, the graphs are straight lines. Non-constant relationship, the graphs are curved. Questions? Okay. Now, gases are all around us, ladies and gentlemen. In this room right now, there are gases that are beating against your head right now as they fly around and they move around the room. The gases don't care. They move in a straight line until they hit something, then they bounce off it and go in a straight line in another direction, kind of like pool balls on a billiard table. They move until they hit something and then they bounce off. So they are hitting the walls, they are hitting the floors, they are hitting your desk, they are hitting you on every square inch of your body that the air in this room can get to. Okay? That is the air that is around us, ladies and gentlemen. And it is a homogeneous mixture. What does homogeneous mean? No, doesn't mean one.
The same.
Homo means the same. What is the same is the ratio of the components in it. In other words, you go in the back of the room, you don't start choking to death because there's no oxygen back there. It is the same as it is in the front of the room. It is the same as it is in the hallway. It is the same as it is as you're walking down the street. Now, the temperature may be different because our air in here is heated to keep the room at a certain temperature, but outside, the same air exists as inside the building. Okay? And it is a homogeneous mixture, a mixture that is evenly spread out, evenly distributed, and has a definite ratio. That is what homogeneous means, by the way. Another way of saying that is it is a solution. It is a solution, just like soda pop, just like coffee, just like tea. And it is made up of various components, ladies and gentlemen. What is the main ingredient in the air we are breathing right now? No, not oxygen. Nitrogen. There is oxygen in the air too. Yes, you are correct, and that's the part that we need. But the air that we are breathing, ladies and gentlemen, is 78% nitrogen gas. What do we use nitrogen gas for in our body? Not a dang thing. We inhale it. Why? Because we can't just get the oxygen out of the air. We inhale the air. We inhale it, goes into our lungs, along with the oxygen. Blood picks up the oxygen, takes it to the different parts of your body. Drops off the oxygen, picks up carbon dioxide, brings it back to your lungs for you to exhale, along with the nitrogen gas that we don't need. So we get rid of the nitrogen gas. 21% of the air that we are breathing is oxygen. By the way, what's this percentage? 99. So these two things make up a majority of the air we're breathing. By the way, 21%, kind of an important number, ladies and gentlemen. 18, 17% oxygen, you'd see a lot more people carrying oxygen with them around. People who have breathing problems, emphysema, lung cancer, things like that. They would have to carry oxygen. There wouldn't be enough oxygen in the air for them to breathe. Few percent higher, 24, 25%, we would never put out what?
CO2.
Nope. What could we not extinguish?
Oh, fires.
We could not extinguish fires. The oxygen content would be too great. It would be almost impossible to stop fires. So this is just the right amount. By the way, it does leave 1%. 1% for things like carbon dioxide, 1% for things like water vapor, 1% for things like argon and other noble gases that may be in the atmosphere, but they make up less than 1% of the air that we are breathing. Now, wherever you go on the planet, this is going to basically be the same. Basically. Now, if you go to a city that is very industrialized, or you go out to California where they have the mountains and they get smog trapped inside of the mountains because it can't move the air as well, maybe you will have a few more pollutants or things in the air, but it's still basically 78% nitrogen, 21% oxygen. Questions? Wonderful. 1% other gases. Okay. So now there are 4 things that affect the gas, and we're going to talk about these all unit long, ladies and gentlemen. Boyle's law, Guy-Lussac's law, Charles' law, ideal gas law, combined gas law, all deal with these 4 different variables that we are going to talk about right now. So here we go, ladies and gentlemen. The first variable that affects, or factor that affects a gas, is pressure. Now, what is pressure?
Hold on. Amount of force applied to a certain area.
Good. That is the definition of pressure. Now, it is the amount of force applied to a certain area, ladies and gentlemen. That is the definition of pressure. Yes. When we talk about a gas, we have to describe its pressure. Before, I told you things were at what pressure? STP, standing for standard temperature and pressure. Okay? Standard pressure is a set of conditions. Okay? Standard pressure is a certain amount of pressure that is on us most of the time. However, pressure varies from day to day based on the weather. Okay? So it changes slightly. So pressure is the amount of force applied to a certain area. Volume is the second factor that affects a gas. Volume is what? The amount of space something takes up. So the volume of gas in this room is basically the size of this room. However, you could have a balloon. The volume of the gas in the balloon would be whatever size that balloon is, ladies and gentlemen. So, volume is another factor for the amount of space a gas occupies. The third, ladies and gentlemen, is temperature. What is temperature? And give me the scientific definition that I have given you. What is temperature?
Energy in particles of matter.
The average kinetic energy in particles of matter. Now, please think about this for a minute. What 2 factors affect kinetic energy? The what and the what of an object. The mass and that would be potential energy. The mass and what?
Gravity.
Well, think about it. Kinetic energy. Kinetic means the object must be what? Moving. So, what does that mean? What affects? No, not volume.
Wait,
not
what was the first one? Mass?
mass.
Energy?
Velocity. Mass and velocity determine how much kinetic energy an object has. Now, we spent a lot of time talking about kinetic energy before. Okay? Cynthia and I run a race.
She's
We what?
You're done. She's winning.
We finish at the exact same time.
You're good.
That'd be a miracle.
It would be, but if I hit you in the knee hard enough, I can run just as fast as you. So we finish the race at the same time. So we have the same what?
Velocity.
Velocity. We don't have the same what?
Definitely not mass.
Mass. So which one of us has more kinetic energy?
Me.
You.
Me.
Oh yeah.
Why?
You have more mass.
Thank you.
More mass.
Because I have more mass. If I'm moving at the same speed as Cynthia, I will have more kinetic energy. Yes, Isaiah, what can I do for you? You want to go use the bathroom right while I'm in the middle of teaching? Please, go ahead. Go. Go. You're only missing important stuff. That's okay. So, again, Cynthia and I run a race. We finish at the same time. That means we had to have the same velocity. That means that for me to have more kinetic energy, I have to be heavier than her. Perfect. Great. Now, What is the same about the oxygen in the, or let me ask you this. What is the same about the oxygen in this room and the oxygen outside the school right now?
Same amount.
It's colder out there.
What's the same?
It's
Think in terms of what we were just talking
still
about.
made up of
Has
H2O.
nitrogen.
I mean,
You say
I said H2O.
Same ratio? Oh,
Okay, so let's make this even simpler for you. The oxygen in this room and the oxygen outside have exactly the same what?
formula?
Which is?
O2.
Nitrogen.
Which is-
1% of
means
the
what?
other thing,
Same
and
oxygen.
It is the same
Same
oxygen. Yeah.
atoms. Same.
No, there's a lot more oxygen outside than there is in this room. Why? Because there's a lot more space outside.
Formula
But what
mass?
is this? Okay, which means the what of the oxygen in here and there is the same.
velocity.
No.
There's so many.
Well, it's not right. What do you want me to do? Go, yes, but no. I could do that, but no. What's the same about the oxygen in this room and the oxygen outside?
I don't know. Just tell us.
Well, there's only two things we're talking about. What are the two things that affect kinetic energy?
Mass.
And
Velocity.
velocity. Mass and velocity. So what's the same about the oxygen inside now?
The mass and velocity.
No.
The formula mass.
Which means the what?
Mass.
The particles.
She just said mass and velocity. I told her it's wrong. I'm going to tell you it's wrong too.
The formula mass.
Which means the what?
The pressure.
The mole.
If you would drop one word from that, you would be so right.
The volume.
The
mass!
Dude.
You kept saying formula mass.
And then I
The
said
mass.
mass, and you were like, no.
The mass is the same. The mass is the same. Yes.
Don't you regret
Again, I'm just in the middle of teaching, but if you need to go, go. If you want to miss out on stuff, your choice. So, the mass is the same for the particles outside and inside. What is different about the particles in this room versus outside? Just the oxygen atoms.
They're warmer
Where?
in here.
Which means they have more what?
Velocity.
Why?
It's warmer.
Which means what? What does warmer mean? Think about the definition for temperature.
Has more kinetic energy
Thank you. Where?
in here.
In here. Now, what is the only way the particles in here can have more kinetic energy than the particles outside?
If they have more
Mass.
We just said they had the same mass. So what's the only way they can have different kinetic energies?
if they have more
There's-
velocity.
Which ones?
The ones in here.
Good. So if we heat something up, what can we change about it? Velocity. What can't we change about it? The mass. We cannot make the particles in the air any heavier by adding energy to them. But we can make them move faster, right? We can make them move faster. And the particles of air in this room are moving faster than the particles of air outside because the temperature is higher in here than it is out there, which is what average kinetic energy is, right? Good. I hope you're all getting this. Questions? Go ahead. Ask the question. What?
No.
Fourth factor that affects a gas. The fourth one, oh, by the way, temperature must be in a unit called Kelvin. We'll get into explaining why. Okay, not right now, but it has to be in Kelvin. Fourth factor is the amount of gas. How much gas there actually is. When is a time when you have put more gas into something? Where have you put more gas into it?
Into a balloon.
The air.
Thank you. Let's go with Kayanis because it's a lot better than yours. Okay? So, what did you say?
Into a balloon.
Okay, so you put air into a balloon.
Mhm.
You change the amount of air in the balloon. What happens to the balloon?
It gets bigger.
So, what else changed? You changed the amount of gas. What else changed?
The volume.
The volume. You can never change one of these things without changing something else. Those are gas laws. You cannot change one of these things without changing something else. Now, you could change more than one other thing. But if you change one thing about a gas, any one of these four, something else has to change as well. That's what this whole unit is about. If I change this, what happens to this? If I change this, what happens to this? And you're going to learn it. Okay? By the way, amount of gas is measured in moles. Huh, funny. We just got through a whole unit where we were working with moles. Okay? We were working with moles. Okay? So, there you go, ladies and gentlemen. Questions? No? Wonderful. Let's move on. Excellent. Good? Okay. So, now, when you talk about pressure, ladies and gentlemen, there are 4 basic units that we will use. We will use millimeters of mercury, we will use ATM, we will use PSI, and we will use kPa. And by the way, ladies and gentlemen, these 4 units will help you identify if your number is talking about a pressure. So you better write them down somewhere. Because when you're looking at a problem and you go, well, what does that number tell me? I'm going to say, well, since the unit is mmHg, it tells you pressure. Since the unit is kPa, it tells you pressure. Since the unit is ATM, it tells you pressure. The unit will tell you what kind of measurement it is. Just like meters would tell you you're measuring. Gosh, thank you. I was hoping for a quicker answer on that. Okay. Now, second variable. Volume. 3 different units for volume in this unit. Liters, milliliters, cubic centimeters.
And these are the only ones that we're gonna see, like ever.
Yes. Now, granted, technically for volume you could see cubic meters, but we won't use it in this unit. These are the units that you are going to see. Liters, centimeters cubed, or milliliters. Okay? All right, wonderful. Now, temperature. Normally, I would give you temperature in degrees Celsius. Why? Because that's what every thermometer that I have in this building reads in. I've never seen a thermometer that reads in Kelvin. There are some. I've never seen one. Never used one in a class. But we can easily take and convert Celsius into Kelvin, and we will teach you how to do that tomorrow. Okay? And for gas laws, it has to be in Kelvin. We will explain why. So again, if you see the unit of degrees Celsius or Kelvin by a number, it's telling you that it is a temperature. By the way, notice no degree sign with Kelvin. Just the symbol K. All righty. So then, ladies and gentlemen, the amount of gas, we use the letter N to represent this. By the way, I should have said that. Pressure, we're going to use a capital P. Volume, we're going to use a capital V. Temperature, we're going to use a capital T. But for amount of gas, we use a lowercase n for number of moles. Okay? And the unit will be moles. Questions? Now, please think about this. What other unit could I give you amount of gas in?
This last unit?
Liters.
I wouldn't do that because it would confuse you here. What other unit could I give you the amount of gas in?
Oh, like particles?
I could, I won't.
Like
But you're right, I could do particles.
atoms?
I could do atoms, but I won't because those are still particles.
Oh.
Grams.
Thank you.
Oh,
We could give you the grams of a gas, which you could convert into moles using formula mass, which we used in the last unit. Questions? Wonderful. So let's talk about pressure, ladies and gentlemen. Okay, let's talk about pressure. I need a volunteer. Who would like to volunteer today? Thank you, Cynthia. Come on up. Come on up. Stand right in front of the class. Cynthia is going to help me with a very simple demonstration, ladies and gentlemen. Cynthia is going to help me with a demonstration about pressure. Cynthia is going to help me with a bed of nails. Okay? Cynthia, you're not afraid of a bed of nails, are you?
What if she gets like, what is that thing called? Tetanus.
She won't.
Oh, he's gonna lay
She
on
has
it.
no chance of getting tetanus because she's going to be standing on a bed of
Of
nails.
course, you picked the lightest one.
Cynthia, can you stand on a bed of nails for me?
You can be the smallest person in here.
Zach, that's what he chose.
Yeah, no big deal, right? Easy, correct?
Yeah.
Okay, good. So you're going to stand on a bed of nails for me. All right? You're going to stand on this bed of nails
This is
for me.
Pick the latest one.
Okay? So,
Enjoying this.
well, before you enjoy this, 2 rules. Number 1, take out your headphone. Put it down. It might put you over the weight. Okay?
Okay.
No rocking back and forth.
Okay.
And no jumping up and down.
Okay.
Oh my gosh, please jump up and down.
All right.
Crack them like a balloon.
Hold it!
Shut up.
I never said I was ready! What are you doing?
Oh wow.
She is enjoying this way too much.
Wait,
Way too
I'm
much.
trying not to laugh. Don't make me laugh.
Don't make you laugh! You got the easy part of this job and you're complaining?
Well, you told me not to rock, and I was laughing, so I was
Oh
rocking.
my gosh. We need to check, ladies and gentlemen. She was rocking back and forth quite a bit.
Just a little.
That hurt.
No leaks. We're doing good. We're doing good. Hold it, you're not done.
Oh my
Come on back up here. KP, come with her.
Oh.
Can't be able to stand on top of you.
No.
Okay. Now, in terms of pressure, there are two factors that affect pressure. Anyone know what they are?
Mass.
Nope. Kind of. Kind of.
Force and area.
Force and area. So mass does affect which one of those?
Force.
Good. Force. Mass provides a certain force, correct? Second is area. So let's start by changing the force. So you guys are both going to stand on here at one time. Okay? All right. So,
We're both gonna stand
Here
on
we go.
it.
okay. Again, no jumping, and I'm looking right at you, KT. No jumping, and try not to rock too much back and forth. All right, let's go.
Oh, me?
Both of you.
At the same time?
At the same time. That's the only way to change the force.
You go first.
Oh my. Oh my. Oh man. All right, don't rock. Don't rock. You're not rocking. That's pretty good.
No,
Nicely done. Okay. Am I
Don't
turning
move,
blue
don't move.
yet?
don't move.
Okay, you can get off, please. Thank you. Wow.
Are we done?
No, we're not.
All right, Aiden, your turn. All three of us.
Okay. So what did we change? Which changed the what? The force. By changing the force, what does that do? What? Well, first of all, how did we change the force? What happened to it? Did it go up or down? Went up.
Yes.
Which means what happened to the amount of pressure that I felt?
More pressure.
More pressure. What was the same though?
The area.
The area. Very good. KP, you think you can handle that part of the job?
No thanks. That's all you.
I saw you.
Cynthia, you think you can handle it?
Get somebody else to do it.
You know what's
Okay. Farhan?
Teacher, no.
Austin? Aiden?
Come on, Aiden. Come on.
Really? Come on. I got nobody who's willing to try this? We'll only have Cynthia stand up.
Just wait till Isaiah comes back.
I'm not waiting. He'll be back in 30 minutes. I'm not waiting for that.
Anna wants to do it.
Cynthia's lightweight.
Come on, Aiden. You can do it. Go ahead. Lay down. Lay down. Okay? We're going to start with Cynthia because Cynthia... Go ahead. Cynthia would provide the same what again? Same force. Okay? That is a daunting thing, isn't it? Looking at all those nails. Go ahead and lay down. Just lay down. People get scared about the bed of nails, ladies and gentlemen. So for some people, we need to begin with what we call a starter kit. That's what we're going to do for Aiden. Right here. We're going to start with a starter kit. Okay? One nail. Bed of nail. Not bed of nails. So lay back. Okay?
No, absolutely.
Lay back.
not.
Okay?
Absolutely. So glad I
Let's
didn't
put this
volunteer.
about right here.
No.
Put your hand right where mine is. Right there. Put your hand right there to hold that steady so that when Cynthia steps on this, it doesn't move around. Okay, Cynthia, go ahead. Right on. You gotta stand right on there, Cynthia.
No, you're crazy.
Why?
Dude, this is a crime. He's gonna stab him.
This is a scientific demonstration.
Oh, it's worth it then, I guess.
Why is it?
All for
What
science.
is wrong?
It's gonna stab him.
That bed of nails you didn't worry about stabbing me. Those are rustier than this thing.
That's a
I
lot.
don't believe that. That's multiple though. Has
So
more
what's the
surface
difference?
area.
Oh, now we're starting to use the terms we're talking about. Which one of these has more surface area, ladies and gentlemen? The bed of nails or the bed of nail?
The bed of
The
nails.
nails.
The bed of nails. Okay, you guys can sit down since you're too chicken to do this anyway.
Sorry.
So, the bed of nails. Dude, you get lost? Dude, one more thing. You're over the 5-minute mark. You're not going again. Okay. Now, here's what happens, ladies and gentlemen. Okay. We can change different factors. Now, why would we not want Aiden laying under the bed of nail? Why? Why would it pierce him? These didn't pierce me. I get it. I'm tougher than Aiden. I got it.
Okay,
Good.
sit down. Let's do the bed of nail then. Just you.
Well, Aiden's got to go first, so we see how tough he is.
What are you?
All right. You want to do this one?
You're the one talking.
All right. So you want to do it? We can do it. All right.
You actually can do it?
Let's go. Let's see what happens. You ready, Cynthia?
No. Take your sweater off.
First of all, it's not a sweater. It's a jacket.
It's a
No,
sweater.
that is
It's
not a
a jacket.
jacket.
It's not a jacket.
That's a jacket.
That's a pullover sweater.
This is a jacket from the travel gear for girls basketball from years ago. It is not a sweater.
It's a sweater.
Wow, how can you be
It's a
so
sweatshirt.
wrong so many times in
Mr.
one
Brad,
day?
if I do basketball next year, would you coach?
Definitely not. Okay.
Think about it. You can make me run like 10 laps every day.
Think about it. I'd have to deal with you hours after school every day. No,
It'd be great.
no. Great is not the term that I would use, but thank you.
It'd be great.
Okay. All right, ladies and gentlemen. So let's talk about what happened here, even though Cynthia chickened out on the demonstration for me. All right. So in our first demonstration, okay, we're talking about 3 things here. We're talking about pressure, we're talking about force, and we're talking about area. So with the bed of nails, what did not change? What stayed the same? The area. Area was constant, right? Area was constant. What did change? Okay, what happened to the amount of force? It went up because when we had KP and when we had Cynthia both doing it together. By the way, Cynthia, if someone else had volunteered, I would have taken them. So don't give me that, well, he picked the lightest person, because I don't know that you're the lightest person in this room. But anyway, moving on from there, Cynthia, what would happen to the pressure if we increase the force? It stays the same.
No, it increases.
It increases. Okay? Very simple demonstration. Take your pen or your pencil, gently push it into your palm, then push it with more force. You will feel more pressure.
That's great.
Okay? Now, the chicken out part, the bed of nail, what did we change?
The area.
The area. And what did we do to the area?
It decreased.
Decreased it. Now, I tried to get Cynthia to do it because that would not change the what? The force. She did the first one. Doing the second one, she would create the same amount of force. What would happen to the amount of pressure, though? Okay. Relationship. What kind? Up here.
Direct.
That is a direct relationship. The more force, the more pressure you will feel. Down here, this is an inverse. The smaller the area, the more pressure you will feel. So again, you've got a pen or a pencil. Take the eraser or the larger part and gently poke it into your hand. Flip it around, take the pointy part, poke it in with the same amount of force. You will feel more pressure from the smaller. Now give me some examples in everyday life where we change the area to change the pressure. Give me an example in everyday life where we change the area of something so that we can change the pressure.
Like a small hammer versus a sledgehammer.
But there you're changing the mass, right? There you're changing the mass. But if you did go with a larger hammer, you would increase the amount of pressure that you could create from it. Yes, swinging it at the same speed.
Like the dull end of a hammer versus the sharp end of a hammer.
Okay? The pointy end of a hammer, the part that takes the nail out, if you hit a wall with that, you're going to go through it very easily. The other part, you will not. Think about a golf tee. Placing a golf tee in the ground. Put it in pointy area first, it goes in very easy.
I tried.
Flip the golf tee over and try to put it into the ground, you're probably not getting it through the ground. How about in your kitchen?
A knife.
Why do we sharpen knives?
So it goes through the food.
Okay, but also so that we don't need to apply as much force to generate pressure, to have more control of the knife. If it's sharper, if it's a sharper blade, it has less area. Less area means I can generate the same amount of pressure with a smaller force, or from a certain force I can generate more pressure. We do that. Gentlemen, if you're going to take a girl to prom, don't tick her off if she's wearing heels.
Don't pick her
Why?
up.
Because if you make her mad when she's wearing heels, she can take and stomp on your foot with the back of her heel. If she's wearing flat shoes, it doesn't matter. Cynthia couldn't hurt you. Okay? Because in flat shoes, there would be a lot of what? Area, which means she would have to generate more force, which we all know she can't generate much force. So then there would be very little pressure. However, if she were wearing heels and she takes the heel and slams it into your foot, it would hurt more. It would hurt more. Why? Because it's all about pressure, force, and area. Questions, ladies and gentlemen? Good. Tomorrow we will talk about the air around us and how it affects us, ladies and gentlemen. But that is for tomorrow. I guess we can, we got a few minutes left. We can call it good.